as always, guys, it's just fine to talk to each other about this. You know, it's hard to talk while drawing forces. But once you got your forces, compare and see if you agree with them. How are we doing? Okay. Once you have free body diagram drawn, forces acting, the next thing that we do when we're trying to the rest of it. Well, duh, yeah. I leave some space. They're going to kind of explain that. So once you got that free body diagram drawn, and drawn that anyway. You have to do a different one for each box, right? Right? I know. A little bit too, you have more things because it's got things going. I suppose. What do you think about it? Okay, we won't do it. I'll try it after you do that. Always like a challenge. How many F-net equations are you going to have then? Three. Yeah, because you don't have an X1, because there's no forces acting that B.
If you say like force of B on
You can call them like you want to put that in. I'm just going to leave them like this. So I'm just going to be like. I'm just going to write it like that. And the only reason I say that, Amanda, is that I know how do these forces compare? Based on what we know from the conversation we just had, they're exactly the same. Yeah, they go in opposite directions, right? Or in different directions. I guess the faces, one's going to the right, one's going up. But the magnitude, yeah, that's one of those things that we're going to take away with this, right? Yay, tension, we love it. You guys are so quiet. It's really okay to talk to each other. It's really okay to talk to each other. Or to scream because you're stuck. I don't know what to do. I don't know what to do either. Like, commiserate with each other. It's one of the beauties of physics. You can be stuck together. Being stuck by yourself. Much less lonely. Lindy, did you want to see something from above? Yes, it is. Yep, it's accelerating. Yep. I solved um, which one? I know, right? And it's free too. Like, make sure that I was trying to make something problem. For just a moment. Would that be okay? Okay. I think some of you have gone further than this already, but I just want to point out to you as you're working through this, if you're not sure what to do, that this is a situation where we've got two equations. Here's a group that what the new FN is. Probably maybe have no idea. Two equations with how many unknowns? How many things do we not know? We don't know if it be on A. Right. That's the same equation as this is here, right? And that's and this in the MB. So we have two things we don't know and two equations. And you may all know from classes that two equations is the whole problem. Right? One of two things, if you like this is an equation. You can do it either way. I like this. They're both legal math moves. But I'm going to solve it for B and plug that. That's the way that I like to do them, and I make sense to you. Go for it. Better or worse. But these equations that we how the negatives and positives come from. And then maybe.
Point 2 times 9.8.
How's it going? You doing okay? And I don't get it. Like, that's right. Yes. Either way is fine. Or when should I do 5 times a day? It's plus 5. Right. But this one and this one. This one. Would you have? So I just want to I get it. Just, I really want you, I want you to be very a lot of times you so that's why as long as you're doing consistent, and then and I don't I have 7 because I have 5 plus 2. Double check your negative. Nothing else makes it, did you? Okay. So do you like negative really, really like don't forget me. And then they're like, let's take a look, shall we? We haven't put any units in, and that's driving you nuts, isn't it? It's okay. It's totally kind of very. Oh, don't throw things. That's messy. Let's go back to the beginning, shall we? So, actually, Addison, if you think about it, every number that goes into this equation should be a Newton, except this one. Does that make sense? So if we go back to the beginning, just to keep our units honest from the beginning. So this is okay. And then let's go down here a little bit further. So let's see. So the 19.6 is a mass 2, 9.8, and so here, we agree that this one, I'll write it down here, that this one here, and we know that this is, that was our, and then our A's are still in meters. So then this 9.8 is in newtons, this 7 is in kilograms. That means that we divide newtons by meter per second. Is that okay? Sweet. Thanks for asking. What do we get for an answer? Hold on. Let me get the answer to that question first. 1.4? Oh. 1.4? 0. Are we okay? Yes. Certainly, yes. And like I just said, the negatives are the hard part of this problem. Yeah. Is that what you wanted to ask as well?
I don't know like why you're here's the negative, but I don't know why how I don't know why you put in orbit.
Okay. So let me see if I can answer both questions. Are we okay? And the first yellow state, and other people can don't have to so that part's okay. And then for negative, I'm looking at what's going on for A. That's the accelerating to the right. Everybody agree? Okay. I'm going to call that positive. So this one is going to be positive to the right because of that force. These guys are both positive, and this one has to be negative because it's going in that other direction. Is that okay with everybody? Donald, is that okay? Yes. All right. And then we got this. With this equation here, we're okay with the one with vector on it, right? Again, let me reiterate that I'm writing the vector hat thing just so I can get translated. And then I'm going to look at direction. You all told me you wanted the down direction to be negative. Okay. So we're going to make this one negative because it's accelerating down. And it's accelerating down because of gravity. It's accelerating down despite this force that's pulling it up. That's okay? Mm-hmm. Okay. So then, what now? I have two equations. Each one has two unknowns. Once I put them together, I'm stuck. But I know that this one has an A and the tension force, and this one has an A and a tension force. So it's the same two. The thing that I care about is A. I'm going to solve this equation for A on B. Let's move this guy over to the other side. Is that okay? So then I have A on B is 19.6 minus 2A. Instead of writing B on A on here, I wrote 19.6 minus 2A. So this thing right here is FB on A. Is that okay? Is that all right? Right, right. Yes. And then this was my F of friction. And I just haven't figured out the number for yet. Is that where you got stuck? I'm sorry, that was like the and then my every time the acceleration. And then it was just a matter of doing an algebra 1 problem. Yep. Yep. What's that? Well, no, I mean like this, right? If you have some number minus a number like this, you did an algebra 1. Because of the negative side. I'm just saying. What's up? What was the answer? I don't know. Did we even write it down? Okay. 1.4. 1.4. Okay, are we doing okay? Yeah. All right. So you won't have a problem this hard on an AP. Okay. That is good. The news that I want to tell you is that knowing the process of this is going to make you a better one student approach things that are tough in the future. They very well may ask you to write down the quiz. I'll tell you that AP really contact want to see diagrams, right? They don't care you can cause a lot. Okay? So this part of the process, this is more just yay, we got for us. Okay? Really, this is what I want you to know. We don't have a super lot of time. What I'd like to do right now is to start the analysis that we will use for the lab. Similar to this, pretty much the same deal, but I want to look at it from the diagram perspective because we haven't done that yet. So we have a card here, and it was on a string, and there was a pulley, and it went down like this, and there was another thing here that this is like all of those washers that were hanging. Put it on the table. Makes it. Okay. And I want to look at this from the lab perspective. Remember what it was that we were trying to find? And was it the acceleration? What did you measure? What did you measure? Right? So here's the thing. This is the beauty of. Do you remember we talked about that linearization stuff? Even when we were on the test, right? You measured mass. Was that in the picture? Okay. So you were measuring mass and you were measuring time. As a simple exercise in physics, you take those two columns of data and you would graph them. Do you agree? And you would graph them and say, oh, look at me, it's so pretty. And you may be able to say, as one goes up, the other goes down or something. But as a physicist, that doesn't tell you very much. So what we really want to know is, how are they really related? So what we want to develop today and next time is a mathematical relationship between those two things that we can then graph intelligently if theory matches here. Right now, I want you to draw a 3x8 diagram for this system. We are assuming that the cards are on a first they have really, really good bearings. That's nice. Now we're going to then draw a 3x8 diagram for that picture. It should look a lot like the one from the last problem. But there aren't numbers to plug in now. Do you notice this? Something like this? Okay? Now, we want to know the relationship between M and T. We even talked about T. No, not really. But we're actually about to acceleration. Yeah, it is. We thought it. We need to take directions into account. Which way do you want to call it? Negative? Down. So I'm going to say negative. I'm going to write this as M2 times G plus F1 on 2. Oops. No vector anymore. Thank you very much. Go away. Thank you. Is equal to minus M2A. Really quickly before you leave me, can you write an F-net equation with the x direction of 1? That was a pretty simple equation, isn't it? Yeah. Like super simple, right? F2 on 1 is equal to M1A. Okay. That's where we're going to start next time. I hope you guys have a great day. Happy Monday.